Okay, for question number 4, it's given that f of x is equal to modulus of 1 minus x plus modulus of x, and this whole is modulus. Now we have to check its continuity. So our given function is f of x is equal to modulus of 1 minus x plus modulus of x. Now we know that the modulus function is negative x, it's x when x is greater than equal to 0, and it's negative x when x is less than 0. So let's try to break this function for these two values of x. So this function becomes 1 minus x plus. Now, for when x is greater than equal to 0, this modulus of x is x, and this gets reduced to 1, and it's 1 minus x. When x is less than 0, this value is negative x. When x is less than 0, so finally our function, it gets break into, so modulus of 1 is 1. So when x is greater than equal to 0, the value of the function is, this function breaks into two values, 1 and the other value is modulus of 1 minus 2x when x is less than 0. Okay, let's check this. Now here x is less than 0, so that means the value of x will be negative. So if we take any negative value, which will give us anyhow the positive value, so we can write that this is positive. So our function gets broken into two parts. First one is when x is greater than equal to 0, its value is 1, and it's 1 minus 2x when x is less than 0. So finally our function is 1 when x is greater than equal to 0, and 1 minus 2x when x is equal x is less than 0. And we have to check the continuity of this function. So our function has, when x is less than 0, it's 1 minus 2x and 1. Now we have to check the continuity of this function at x is equal to 0. Now f of 0. F of 0 means equal to 0, the value of the function is 1. Now let's check its left hand limit. So left hand limit is limit x tends to 0 negative f of x, and the value of the function for x is less than 0 is 1 minus 2x. So this limit x tends to 0 negative 1 minus, this is 1 minus 2x. And let's say now that x is equal to a small value h less in 0. So as x tends to 0, h tends to 0. So let's change this limit to limit h tends to 0. It is now 1 minus 2 into 0 minus h, which gives me limit h tends to 0. This is 1 minus 2 into 0 is 0 plus 2h. And if we take the limit, that is if we put the value of h is equal to 0 here, this is 1. So left hand limit is 1. Let's find out the right hand limit. So right hand limit is limit x tends to 0 plus f of x, and for value of x greater than 0, the function is 1, so it's 1. It's 1. Now the value of the function left hand limit and right hand limit all are equal to 1, so that means the function is continuous function. So this function is continuous everywhere, and we can choose the option D, which says it's continuous everywhere. Moving on to question number 5.